The age when smokers first start from previous study is normally distributed with a population standard deviation of 1.8 years old. A survey of smokers of this generation was done to estimate the mean age. The sample of 35 smokers found that their mean starting age was 14.7 years old. Find the 95% confidence interval for the mean. Okay, here we need to know something. Let's find out what is given. The age when the smokers first start from the previous study is normally distributed. So we are talking about the age of the smokers when they start smoking. So if we study everyone, that is the population, it is found that the population is normally distributed with the population standard deviation of 1.8 years old. So that is the population standard deviation. Sigma is given. Okay, standard deviation for the population is given. Population standard deviation is 1.8 years. So when population standard deviation is given, that is our first case, sigma is given. A survey of smokers of this generation was done to estimate the mean. We want to estimate the mean. That's why the survey is done. What is the mean age this generation start smoking? We want to estimate that. So for that, what is done is the sample of 35 smokers. So that is your n equal to 35. That's your n is 35. Let me use different color for the later. N. They found that their mean starting age was 14.7. So the study found that from the survey, the mean starting age was 14.7 years old. This is the mean. So that is the sample mean X bar. That is your sample mean X bar. We have to find the 95% confidence interval for the mean. Now here, we want to find the confidence interval, but you must be 95% confidence. So this is what we want, 95% confidence interval of the mean. So what we already know is if I want to find the confidence interval, I need the X bar in the middle. I need the X bar in the middle, which is called the point estimate. So here the point estimate is, let's find that. Here, point estimate, you can write this down. Here, point estimate, which is X bar, the sample mean is equal to, it's given in the problem. Sample mean is 14.7. That is given to you. 14.7. So sample mean is given to you. That is a point estimate. Now what I need is I need the sample mean plus some value and sample mean minus some value. So I need the sample mean plus the margin of error. And I also need sample mean minus the margin of error. I need these two values. So what I actually need is the margin of error. Now the margin of error, if you look at your formula from the previous slide, margin of error is equal to Z sub C times population standard deviation divided by the square root of n. Now, if you look at this question carefully, you have the population standard deviation. It's 1.8. You have the sample size n is 35. But we don't have this Z sub C. We don't have the Z score at given confidence interval. That's the meaning. Z sub C, we don't have that. So what we are going to do is we are going to use the normal distribution and we are going to find this Z sub C. So let's find this together. So when I say 95% confidence interval, meaning of that is in your normal distribution, the area in the middle, this is the 95% area. This is 0.95. This area is 95%. That is the meaning of that. This is your 95% area. And what I want is Z sub C. Z sub C is this Z score here. This is called the Z sub C. So that the value on the other side, this one will be negative Z sub C. Negative Z sub C. I know that this area is 95%. So out of 100%, 95% is here. So on the tail here and here, the remaining 5% is divided into two parts. So here we have the 95%. So remaining 5% is divided into these two parts. That is, this will be 2.5%, this will be 2.5%. So we can label that. This is at the tail, that is 2.5%. So let's label that. This area is 2.5%, that is 0.025. And this one here is also 0.025. So once we have the area on the tail, we can easily find this Z sub C. So what we already know, in order to find the Z score, we use the inverse normal, if you remember. It is inverse normal in our calculator. Inverse normal. We need the area in order to use the inverse normal. You have to be very careful here. We want this Z sub C. So if I want Z sub C, I want all area to the left of that. So all area to the left of that, you may use your calculator to add this. From here up to here, the area is, you can see this area is 0.95. And area over here on the left tail is 0.025. So if I want 0.95 and 0.025, that is 95% and 2.5%, it is 97.5% or 0.975. That is the total area to the left of Z sub C, because whenever you are using the inverse normal, you need all the area to the left of that. Now the mean for the Z score, the mean is 0. Standard deviation is 1 for standard normal distribution. Whenever we are talking about Z, we are talking about standard normal distribution. Now you can use your calculator to evaluate this. So if I use my calculator to evaluate inverse normal, 0.975, mean 0, standard deviation 1, I obtain 1.96 in my TI-84 calculator. So we have Z sub C is 1.96. We need this, and we were calculating this because we were about to calculate the margin of error, and we don't have that value. That's why we did all this calculation to get this value Z sub C. So let's substitute here. So Z sub C, we just got 1.96, then multiply 2. This one, the population standard deviation, here it is 1.8, 1.8, and we have to divide that by the square root of n. N is 35. Now, I want you to use your calculator to simplify this one. I simplified here and I got 0.3043. That is the margin of error. Yes, the actual value after this simplification should be 0.5963. So that is the margin of error. What we are looking at is we want to find the confidence interval. So you can see here, in order to find the confidence interval, we need to know that we need two values. The first one is mean minus the margin of error, and the second is mean plus margin of error, so that we can say the true mean lies between these two values. So this is where the true mean lies. That's why we need the mean minus margin of error and mean plus margin of error. So in next step, we are going to calculate those two values. So this implies mean plus margin of error. Let's do minus first. Mean minus margin of error is equal to mean, or the point estimate is 14.7 minus The margin of error, which we just obtained here, 0.5963. So we are going to subtract that in calculator. 14.7 minus 0.5963. And we get 14.1037. So that is the mean minus the margin of error. This lower value, the lower end of the interval. We also need the upper end of the interval. It is mean plus margin of error. So let's do that. Mean plus margin of error. Mean is 14.7, or the point estimate is 14.7, plus the margin of error is 0.5963. So if we add, make sure you add that in your calculator. So when you add, you should get 15.2963. So the lower value for the interval is 14.1037 and the upper value is 15.2963. So meaning of that is, with 95% confidence, see, we are calculating the 95% confidence interval. We use that 95% to calculate this Z sub C, which we use here. So with 95% confidence, we can say that the true mean age the smokers will begin smoking lies between these two values. That's what you need to write as the conclusion. So let's write that down. With 95% confidence, we conclude that the true mean lies between 14.1037 years and 15.2963 years.